Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Magnetic Mark. Thanks for the suggestion, Mark. You asked, how does a compass find north? If you've ever held a compass and wondered, how does this tiny needle always know where north is? You're not alone. Today, we're unraveling the magnetic mystery that makes this little gadget tick from its ancient origins to the science behind its swivel. So, if you've ever gotten lost and wished for a trusty compass, or just want to impress your friends with some magnetic trivia, stick around as we dive into the fascinating world of compasses, right here on Explaining Everything. To understand how a compass works, let's first talk about magnets. You've probably played with magnets as a kid, sticking them to your fridge or pretending they're magic. Turns out, the Earth is basically a giant magnet. It has a molten iron core, and this core's movement creates a magnetic field. So, think of the Earth as one big fridge magnet, just without the cool dinosaur pictures. Now, the compass needle is made of a magnetized material. When it's floating freely, the needle aligns itself with the Earth's magnetic field. One end of the needle points toward the Earth's magnetic north pole, and voila, you've got your directions. It's almost like the needle is hypnotized by the Earth. Look into my magnetic eyes. Follow me to the north. Ooh. Here's where things get spicy. The north your compass points to isn't actually the geographic North Pole where Santa hangs out. It's pointing to the magnetic North Pole, which is, let's just say, a bit of a wanderer. Magnetic north isn't even a fixed point. It moves every year because the Earth's magnetic field isn't exactly stable. Imagine trying to find your way with a compass 200 years ago. You'd be following a needle that was, quite literally, leading you on. To make navigation accurate, we have to account for magnetic declination, which is the difference between true north and magnetic north. Depending on where you are, this can make your compass a little directionally challenged. It's like the compass is saying, north-ish? This way, probably. The key to the compass's magic lies in that swiveling needle. It's balanced on a pivot point to reduce friction, allowing it to respond to the Earth's magnetic field with minimal resistance. Basically, the needle's job is to chase the magnetic field lines like a dog chasing its tail. Only it actually catches them. Those magnetic field lines run from the magnetic South Pole to the magnetic North Pole, and the compass needle aligns itself along these lines. It's like a really persistent dance partner that refuses to let go, twirling its way toward the magnetic pole no matter how many times you spin it. Why doesn't it point south? Good question. The needle's north end is designed to be attracted to the Earth's magnetic North Pole. But wait, magnets have opposite poles, right? So technically, the Earth's magnetic North Pole is like a magnetic South Pole in disguise. Confused? Don't worry. Just remember, opposites attract, even when it comes to Earth's magnetic drama. It's like the magnetic North Pole catfished the compass needle into thinking it's a match. What if you're near the equator? Great question! Near the equator, the Earth's magnetic field is more horizontal than vertical, so the compass needle can get a little wobbly. Think of it like trying to walk a tightrope while juggling flaming bowling pins. Tricky, but not impossible. That's why special compasses are sometimes made for different hemispheres. So, they're less likely to tilt and give you inaccurate readings. Now, before you start trusting your compass like it's your best friend, beware. There are things out there that can mess with it. Nearby electronics, power lines, even that fancy smartphone in your pocket can interfere with the needle. It's like your compass gets stage fright when it's surrounded by too many magnets. And let's not forget lodestones, those naturally magnetized rocks that can throw your compass into a spin, literally. The compass has been around for a while. We're talking ancient China, where people used lodestones in bowls of water to point north. These early compasses weren't exactly pocket-friendly. Imagine hiking with a bowl of water in your hands while trying not to spill it. Not ideal. By the time compasses made it to Europe, they had gotten a little more sophisticated. Mariners in the Middle Ages relied on them to navigate treacherous seas, proving that even back then, people were willing to trust a tiny needle over their own sense of direction. And honestly, same. These days, most people rely on GPS, but compasses haven't gone out of style. Hikers, campers, and anyone who likes to pretend they're Bear Grylls still carry one. And let's not forget, unlike GPS, a compass doesn't need batteries. It's a simple, elegant solution to a complicated problem, one that stood the test of time. So, how does a compass find north? It's all thanks to the Earth's magnetic field, a magnetized needle, and a whole lot of science. Whether you're navigating the great outdoors or just trying to impress your friends with random knowledge, the compass is here to point you in the right direction, unless you're standing next to a giant magnet. Then you're on your own. If you enjoyed unraveling the mystery of compasses or learned something new, give this video a thumbs up and subscribe for more curious content. And if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.